Hello, Team 613. I wanted to talk to you a little bit about the electrical system on the robot. This is kind of an introduction, Electrical System 101. So let's go ahead and take a look at some videos here. All right, so you may remember last year we built this robot, and here we have a video that we took of us prototyping it. And when it comes to the electrical system, it's pretty basic. There's a motor on here, right here. We just plug in the motor right into the battery, and the motor's running, and you can't see it, but there's a Acme screw that's being turned by the motor to move the robot up and down. So all you need to get this motor to run is a battery, and you know this from everything from toys you've played with and everything like that. You really need to put something called a circuit breaker in between the battery and the motor, and the circuit breaker, if it senses that too much current is flowing through it, will automatically shut down the circuit. So, but essentially all you need are a motor and a battery to make a motor move up and down. Now, if you notice, however, that was our prototype. Here's our finished product. So let's watch this for a little bit. So we've got Team 613 right here. We're running up to the pyramid. It's the same component. It's moving the robot up and down. But do you notice what the big difference is here? Okay, well, besides for the music, the big difference is that we don't have a person standing next to the robot with wires coming out, plugging it in and plugging it out of the battery. So, in fact, everything that Kunal was doing in the last video has to be done remotely here. So how is it? How does this robot automatically turn its motor on and off without a person being there with a switch? All right, let's go to the next one. All right, so, well, here's a whole bunch of components on the robot. This is a base that we created at the beginning of last year. We're going to see if we can go and understand what a lot of these different components do and figure out what all the names of them are. But let's see what happens when they're all working together. So this is kind of the guts of our robot here. All right, so as you can see, our robot is it's running here. It's we're turning these motors. There's a motor here and a motor here. We're turning them on and off, but we're doing it all remotely without a person having to be there to physically throw a switch or take wires in and out of the battery. So let's try to understand, name some of these components here. So here's a close-up of that same robot. All right, so here are some of our components. We have a battery, we have our power distribution board, we have the wires from the power distribution board then go into the motor controller, and then you'll notice from the other side of the motor controller you have wires that connect up to the battery. I think this is actually before we connected it, but if it was connected properly, wires would be coming here and going into our motor rather. All right, so we've got those. We've got this box over here, it's called the C-RIO. We've got another box over here called the digital sidecar. And this is it. Now, if we wanted to, you could actually do an experiment. If you got rid of the C-RIO and you got rid of the digital sidecar, you could actually plug the motor right into the power distribution board and the motor would run. But what would be the problem with this? What did we see with the motor that when we plugged it right into the battery? Right? The motor was just constantly running at a constant speed. The power distribution board just takes electricity from our battery. It has some circuit breakers in there, which, as I was saying before, will shut current off to the battery if there's too much current running through it. So this is kind of a safety mechanism on here. These black things are the circuit breakers. And then would output energy directly to the motor. Okay, so that's really all we need to make this motor run, except it's only going to run at one speed, and we don't have any way to turn the motor on and off remotely. The only thing we could do is unplug the battery or plug the battery back in to shut it on and off. So that kind of gives us a clue as to what these other things are here. They're not needed to make the motor run at full speed, but they probably have something to do with our ability to remotely turn the motor on and off and adjust its speed. Now, if you follow the wiring here and kind of trace the flow of electrical energy, it starts with the battery. All right, the battery connects up with your power distribution board. And your power distribution board, you'll notice there are wires that come here to the motor controller. And then if this had been hooked up, you'd see wires coming out of the motor controller and going to the motor. If you look at these other components, which we're not quite certain yet what they do, but we know they're not needed to make the motor run to run at full speed, so we suspect they have something to do with controlling the motor. We have our C-Rio that has this long ribbon cable that goes to our digital sidecar. And then you'll notice there's this three-colored wire that runs along here, okay, and it actually plugs in to the motor controller. And so this motor controller looks like it's key because the electrical current has to go through it, but it also has to get some information. It also has to plug in to these components that we think have to do with controlling the speed of the motor. All right, and actually the motor controller must do that because it's called a motor controller. So let's take a little bit more in-depth look at this motor controller. So if we look at it up close, what we have are some different connections. Right here is where we connected the electricity to come from the power distribution board. Here are where the wires connect to go to the motor, and here are where the wires connect from the digital sidecar. And so we have two inputs and one output on this motor controller, and since this has all the electricity running through it that goes to our motor, plus since it connects to the components that we thought kind of control the motor and make it run at different speeds, this must act like a switch, right? This is that automated way that we can automatically turn the motor on and off, except instead of using our finger to switch it on and off, we use, right, this electrical current that we send here. The electrical signal that gets plugged into here tells this motor whether to turn itself on, tells it whether or not to send electricity to the motor. So it's acting like a giant switch. In fact, it's even a little bit better than a switch because not only can you turn it on and off, but you can also turn it to a medium speed. So you can kind of vary how much electricity goes. You can have it go at 100%, at 50%, 0%, and you can even, this motor controller can even make the motor run in reverse at 100%, 50%, 0%, or anything in between by flipping the polarity of the electrical current. And so that's really what our motor controller does, is this is that switch that answers that question, right? How can we get from having a person manually plugging a motor into the battery to being able to do everything remote control, as we did here? So if we go back to our pieces here, right? The battery, the power distribution board, are the pieces that are in charge of getting all the electrical current, the power to the motor. And then the motor controller, the C-Rio, and the digital sidecar are the pieces that you need in order to control the amount of current that goes to the motor. You know, do we want the motor to go at 100%, 0%, 50%? Do we want it to go into reverse? That's the job of these other pieces. And these are actually broken up into two different systems. The battery, power distribution board, and motor are often called the power distribution systems, and the C-Rio, digital sidecar, and motor controller are often called the signaling system or the control system. In fact, if you look on Edmodo, I've posted two different diagrams for the electrical systems. One details how all of the power distribution system pieces hook together, and the other details how all of the signaling system components hook together. And so this is kind of a big idea when it comes to these electrical things. You should look for the components that are distributing power, and the components that function to control the power and send signals from one component to another. So, well, how does this motor controller actually do this? So I just want to give you a real quick explanation to how does our dimmer on the motor controller actually work. So if you were to graph the voltage that's going into the motor controller versus time, it's just a constant 12 volts. All right, and if we didn't have that motor controller there, our motor would just be running at full speed, 12 volt input constantly. However, when we send a signal to that motor controller from our digital sidecar, which is part of our signaling system, what happens is the motor controller actually turns the voltage on and off. Or turns the electrical current on and off. So this is what's being outputted from our motor controller and going to the motor. So you can see we're at 12 volts and then it shuts off, 12 volts and then it shuts off for a little bit of time, 12 volts and then it shuts off for a little bit of time. If we tell the motor controller that we want to run it slower from our signaling system, it actually only outputs 12 volts for a shorter amount of time and then shuts the electrical current off for a longer period of time. And so on average, the motor is going to run slower than before. And if we tell the motor controller that we want to run backwards kind of slow, it sends out a negative 12 volt current to our motor. This is actually, if you look at this, these are commonly called pulses, and what we're doing is we're changing the width of these pulses. So the motor controller is also known as a pulse width modulator, or PWM. You've probably heard our word say that, or have heard us say that before. And the reason it's called a PWM is because what it does is it modulates another word for changes the width of these electrical pulses that we're sending to the motor. So that's why it's called a pulse width modulator. Obviously, if we told the motor controller that we don't want the motor to run at all, it's not going to output any voltage. So if we graphed the voltage versus time, it would actually look like this. By the way, there's actually an instrument you can hook up to the motor controller outputs that will show you a graph of voltage versus time. It's called an oscilloscope, which is just a fancy tool. It's like a voltmeter, except it actually graphs voltage versus time. So it's kind of a fancy voltmeter. That's a useful tool that a lot of people use. Anyway, I wanted to end on this kind of central idea that we were talking about, which is that we had some components on the robot that were in charge of distributing power, and we had other electrical components on the robot that were in charge of sending signals and information to components about whether they should be on or off. This idea of separating those two systems is something that you actually run into quite a bit in electronics. For example, here we have a CD player, and we have another thing here called an amplifier. And you might have a setup at home that does this, or they might all be integrated into one component at home. What you do is the amplifier takes power from the outlet. It's just a normal power that you get from the outlet. It also gets a signal from the CD player that tells it what it should do with that power, what the intensity of the power should be as time goes by, in order to output a signal to the speakers that will produce the music that you want. And so this is a separation of the signaling, which is done by the CD player, and the power from the outlet, which the amplifier takes, and then takes the signal from the player and amplifies it, so it's a much more powerful signal, powerful enough to run the speakers that you've hooked up to this. Okay, so we talked about some of the components on the robot. Important point is just try to go back, make certain you know all the names of the different components on the robot, what their job is, what's connected to what. And if you want to, take a look at those diagrams that I mentioned that we've posted, the signal system diagrams and the power distribution diagrams. Okay? All right.